Okay, so this is like my 8th try. I'm really suck at explaining. Oh, what am I doing? Configure video. Alright, let's see if this works. Okay, it does work. Okay, we're fine. Oh my god. My friends are texting me. Okay, so this should work. Yeah, we're recording. So this is rotational kinematics. This is on like unit, or the end of my unit 4, and then like the beginning of my unit 5 for my AP Physics class. And this is just one problem that I'm gonna be doing, and I'm doing it as a review because I already done some problems on this, so I think they're all really kind of the same thing over and over again. And it was pretty. From my own knowledge, I think it should be recording. I don't have it up. Okay, it should be. If everything goes smooth. Let me move my camera. So let me read out the problem. So a rifle is a long. I'm gonna be doing this on my iPad as well as my computer. A rifle is a long gun whose barrel has been grooved, or a rifle on the inside with spiral channels. I'm not reading the book. Bullets fired from a rifle barrel spin. This gives them greater stability in flight and thus greater accuracy when fired. Since 1964, the standard infantry weapon in the U.S. Army has been the .22 caliber M16 rifle. Wow. Due to the rifling, a bullet fired from M16 rotates 2.5 times on its journey from the breech to the muzzle. Given a barrel length of 510 millimeters and a muzzle velocity of 950 meters per second, determine the average translational acceleration. So that's the first one. So the barrel length, so hard. Barrel length is going to equal to 510 millimeters. Oh fuck! How do I erase? 510 millimeters. Or if I'm going to put it in the calculator, 0.510 meters. Oh my god. That's 0.510. And then the muzzle velocity is 950. I'm not going to write all this out because I just realized it's going to be tedious. 950 meters per second. And then the bullet completes 2.5 times on this journey. So then it's just like times 2.5. Wow. That's bad. It's just 2.5 times before leaving the barrel. So for average translational acceleration, use the kinematics equation, which is velocity to the second power equals velocity. So this is initial, or this is final velocity. This is initial velocity. Oops. Got my ear. Plus 2 acceleration, and then it's displacement. Oh my god, this is so bad. I don't even care. Okay, so this is pretty easy because you just plug in everything all at once. And so if I'm trying to find the average translational acceleration, all I'm gonna do is just like rewrite the equation, and I'm gonna actually rewrite it in a way that people could decipher it if they're gonna read my paper. So notice how like acceleration is on the right side of the equation. All I'm gonna do is just basically revert it into a way that is so that acceleration equals to what the velocity is gonna be. So when you solve for A, just move everything aside, and then you have to divide the final velocity over the entire equation. So that's V initial velocity over 2. Because already this. Bro, my 2 looks like a Z. 2, and then displacement. So when defining the variables, our displacement is going to be the length of the barrel. So S is equal to, because we're going to put this in the calculator, it's going to be 0.510. initial velocity is what was said, muzzle velocity, or well, it would just be 0. It'd just be 0. The initial 0. But then the final velocity is given a barrel length of 510 millimeters and a muzzle velocity of 950 meters per second. That's going to be our initial velocity. Please tell me I'm still recording. I am. Oh my god, this is going smoother than before. So because we're solving for acceleration, we're just going to plug all this into the poorly written equation I have here. Let me use a different color. Choose red pen. This is the equation. My writing is so bad. Alright, let me make sure I write this on my laptop, or my iPad. So, what am I going to put? Acceleration, solving for accelerations. 950 to the second power minus the initial velocity, which would be 0. And then you divide, well, you can get that, but you divide that all by, what is it, 2 multiplied by displacement, and 0.5 0. That's 1.02, so our numerator is going to be 902 fuck, just ignore 902 500. Bro, I can't restart the recording. Alright, whatever. I can't pronounce shit. And then our denominator is going to be 1.02. And then you just divide that. English isn't my first language, even though it's numbers, but. Okay, so then we got this. So that means the bullet would, you should get like a pretty lengthy number in your calculator. 803. I'm really just simplifying this because I'm not like no professor, so I'm just explaining this in my own manner. So the bullet, it's a pretty weird number, but basically the bullet would accelerate at 880,000 meters per second squared. Yes, squared inside the barrel. So that would be the average translational acceleration, as you're going to use the kinematics equation, and then you're just going to rewrite the equation to solve for A, which would be the acceleration. And then once you rewrite that, you enter all the values that you already have in, and whatever you get out of your calculator would be the whatever you get out of the calculator would be how many meters per squared second squared inside the barrel. So that's the first problem. I gotta delete all this because I can't. Are we for real? It's gonna take a little while. How do we rewrite this? Or I gotta delete all this because I only have a little bit of space and I can't go any further than this page or anything. I don't even have a whiteboard. I'm using a snipping tool right now, so maybe in the future I'll have something more prepared. I'm also doing this out of pure boredom, but we can keep that circle. Oh, I almost restarted the whole thing. Okay, so for the second one, the average angular acceleration in radians per squared. So finding the time spent in the barrel is just very simple because all you're going to be using is the average velocity equation, which I have written here. Although I'm trying to remember this off my head because I do have a script in front of me, but this one's easy because this is like from unit 2. So this would be oopsies. No, velocity v. So substitute the value final velocity plus what is it? Oh, initial velocity over 2. Right? And so then the average angular acceleration, so all you're going to plug in are the same, literally just basically the same values. I mean, it's actually easy because all you're doing is just doing the 950 meters per second, and then initial velocity, which would be 0 again, so it would be 950 over 2. And so then you plug in your calculator. Yo, what is my data plane? Yeah, well, I did it wrong. 470. Yeah, okay. So you get 475 meters per second, and then we use the formula to find in radians per second squared, which would just be time. So then T equals, which would be your displacement over your the 475 meters per second. Yo, I look stupid. Hello? Hello. Alright. And then your displacement again, 0.510 over 475 meters per second. And so then that should equal 0.001. No, I put 85. It's 05 or 75. Right? What is it? It's not 475. So rounding it, you get 0.0011. So it'd be like about 0.0. It'd be 0. Fuck me. The bullet spends 0.00011 seconds inside the barrel. I should have written this before. And 0.11 seconds inside the barrel. And then what did I say before? I have it up. Wait, I have it in my calculator. What was it? 808. Acceleration equals 800 meters per second. So, alright, as of now, we got 2 out of the 3. It's really not that bad. I'm just really bad at explaining. Alright. I also have my worksheet equations in front of me, or my equation formula. So. I almost pressed new. Oh my god, that would have been so bad. The final angular velocity in rotations per second. So, angular velocity, that means you're just going to angular kinematics equation. And so, that is written as, this variable here is your angular displacement. And so, what did it say before? 2.5 times on its journey from the breach. So angular displacement would be 2.5 rotations. And this would equal to 5 rad, or 5 radian, because one rotation is 2 pi, or it's 2 radians. So so that's angular velocity. So Where'd my equations go? My equation sheet. Personally, I don't exactly know what each term means, so I'm not gonna like butcher the name or even try to say it. I'm just gonna write down the equation, what it says. I mean, this one's obviously time. Hold up. Plus 1.5. This is angular acceleration, which is what we're actually solving for because it says find angular velocity. So it's gonna be like what we did before in the first problem, or in part A. And then time t, but to the second power. So if we're finding what is it? If we're finding angular acceleration, that means we're going to be doing what we did before, where we just rewrite the equation. But since what is it? Initial angular velocity is 0 because the bullet starts with no spin. That means wait a minute, what? So would I just hold up? Let me just write this. Ignore this. I don't know what. Because I'm just filling in what each variable. Because we already solved that. Plus 1.5 is. Oh, wait. Okay. So, I don't know what this means. I don't know where to go from here, actually. I'm stuck. The first two were fine. I don't know how to find angular velocity. Because I don't know what this means in the equation. This little, like, W O thing. Like, I know it's initial angular velocity, but I don't know what I do from there. If it's I don't know what that means. Honestly, I think I'm gonna cut it there because I don't know what the hell to do. I'm gonna have to actually search it up more. Yeah, I don't know. Yeah, I don't know what it means. Because I know it's 0, but I just write 0 and then it has nothing. It's a nothing, and then I don't know. No, I don't know. I'm gonna search it up. All right, that's it. I don't know what else to do. I give up. That was 19 minutes.